Hello everyone, we're going to take a look at exercise 54, where we're going to now take higher powers and combine them with roots and see how they work. And if you have taken a look at the theory and video explaining the theory, it's not that difficult when we have roots and powers just separately given, right? So what I should say is something like this. Hopefully you have practiced already that this is just the same as a to the power of 4. Not a to the power of anything else, because remember, which number times itself is a to the power of 8, it's a to the power of 4, because a to the power of 4 times a to the power of 4 is a to the power of 4 plus 4, hence a to the power of 8. So a to the power of 4 is the answer to this question. What you just do is divide the power, or the exponent I should say, by 2. What we're now going to take a look at what happens if we have powers outside of the root instead of inside, and also what happens if we have odd numbers. So let's just first take a look at a. Root a to the power of 9. This is exactly the same as this, root a to the power of 9. That's what they explain here. In general, root a to the power of n is the same as the root of a to the power of n. But we cannot stop here, because we have to now simplify this. And 9 is an odd number. So if I divide it, I would find a to the power of 4.5. And this is something we want to ignore, or ignore not. We don't want, because we don't want fractions in our exponent, So what the book does is it's going to split this thing up into a times a to the power of 8. This is the same, because remember, a is the same as a to the power of 1, and a to the power of 1 times a to the power of 8 is a to the power of 9. And this works now, because a to the power of 8, I know. You could split the roots here, right? So this is the same as root a to the power of 8 times root a. And root a to the power of 8 is a to the power of 4. So your actual answer is now this. And this seems weird, but this is the final answer, believe it or not. Okay. So let's take a look at b. A to the power of 3 root b to the power of 5. Everything inside the brackets to the power of 5. So a to the power of 3. And you don't have to write down this intermediate step, but what you would have is this, right? A to the power of 3 to the power of 5 times root b to the power of 5. And this I can calculate. A power of a power means I multiply the exponents, a to the power of 15. And we just saw that this is the same as root b to the power of 5, which I could split out into root b to the power of 4 times root b, right? Which I do, because now this is an even number, so I have a to the power of 15. This I divide the exponent, so I find b squared, and then at the end I'm left with only root b. Okay, let's try another. C. 2a to the power of 3 root a, and it all is to the power of 4. So that means everything is to the power of 4, right? So the intermediate step you could write down is 2 to the power of 4 times a to the power of 3 to the power of 4 times root a to the power of 4. Everything. 2 to the power of 4, of course, is not 8 but 16, because remember, 2 times 2 times 2 times 2. A power of a power means I multiply the exponents, and root a to the power of 4 is the same as the root a to the power of 4, which is the same as a squared, because I divide 4 by 2. And Now a lot of people of course are inclined to write this down, which is a mistake, because now I multiply exponents, powers, which means I add the exponents. A to the power of 12 times a squared, 12 plus 2 is 14. Please do remember the difference between this, right, a squared times a to the power of 3, and this, a power of a power. If you have this, you add them up, a to the power of 5. If you have this, you multiply them, a to the power of 6. Here I multiply them, so I do 12 plus 2, 2 plus 3, what I did here. Okay? And that's your final answer. D. 3a root a to the power of 4 plus 5a root a squared. Let's see if we can do this quicker. Because if you see this, you don't have to write down this intermediate step. This 3a is outside the brackets. Root a to the power of 4 is the same as root a and then the 4 inside of the roots, so that's the same as just a squared plus 5a root a squared. Everything is squared, so 5 squared, that's 25. A squared, that's a squared. Root a squared, a root and a square cancel each other out, that's just a. 3a times a squared is 3a to the power of 3. Remember, there's a 1 here. 1 plus 2 is 3. Plus 25a squared times a is 25a to the power of 3. Hey, like powers I can add up. 3 plus 25 is 28. And remember, when adding up, exponents don't change. So 28, a to the power of 3 is the answer here. Let's take a look at E. Minus 4a squared root a to the power of 3. If you want to, you can do this in one go, but what you are doing is minus 4 to the power of 3 times a squared to the power of 3 times root a to the power of 3. Everything inside the bracket to the power of 3. Minus 4 to the power of 3 is minus 4 times minus 4 times minus 4. So that's negative 64. A squared to the power of 3. A power of a power, I multiply the exponents. Root a to the power of 3 is the same as root a to the power of 3. And maybe some of you already see that that is the same as root a. That's not right here, then it seems like that's the equal sign. You can write this down immediately as a root a if you want to. Why is this the same as a root a? Because remember, again, don't do it here. Remember, root a to the power of 3 is the same as root a squared times root a, which is the same as a root a. Okay, which I write down here. And now we have multiplication, which I can always simplify. Minus 64. A to the power of 6 times a is a to the power of 7. Remember, the exponent here is a 1. 6 plus 1 is 7. That root a is just chilling at the ends. Okay. Now, and let's do f as well, which seems a lot like e. Maybe a bit more difficult, but surely doable. The only difference is now we have 3a instead of just a inside the root. Oh, my power is lower. Okay. Let's just take a look. Again, if you find this difficult, everything is to the power of 2. Everything is squared. So 3 squared, a squared squared, and root 3a squared. The first two shouldn't pose a problem anymore. 3 squared is 9. A squared squared is a to the power of 4. Just be careful what's happening here, because this might throw people off. And if you find this difficult, remember that this is the same as, because you can also assume it like this, right? the mistake that some people now make, let's start with the mistake, is saying this. They only square the a inside of the root. And that's incorrect. What you have to do is square everything inside of the root. So you get root 3a squared, which is the same as the root of 9a squared. And another way to get here, by the way, is saying, well, squaring something, so another way to do this, squaring something is the same as doing something times itself. So then you have this, which is the same. And we know that that is the same as fusing them into one root. And 3 times 3 is 9. And a times a is a squared. So that's another way to find root 9a squared. And believe it or not, this you can calculate, because the root of 9 is 3. And the root of a squared is a. So it's just 3a, which you maybe already saw happening right here, right? You could actually avoid this altogether. The difficult way to do this by just saying, oh, I have a root and a square and they cancel each other out and I have 3a. Maybe that's actually the best way, right? Immediately here and recognizing a root and a square cancel each other out. So I did it the long way here. But you see, it all checks out. 9 times 3 is 27. A to the power of 4 times a is a to the power of 5, because remember, a to the power of 1, and then you get it. Again, maybe I could immediately come from here to here. But you can do it this way, or you can do it this way, or you can just assume roots and squares cancel each other out. And that's something that's going to change quite quickly in mathematics. That way in first grade I always say this is the way you have to do it, this is the quickest, the most correct way. You see here that there were actually 3 different ways to get to the answer from here on. By doing it this way, by doing it this way, or by immediately recognizing that roots and square cancel each other out. And that's something that happens more often the further we go, the more in-depth we go in certain mathematical fields. Good luck, practice this well, you can do it.